The objective of this lesson is to discuss inverse functions. We want to be able to create inverse functions and then also to test to see if two functions are inverses of each other. So first of all, we'll talk about ordered pairs. When you look at a set of ordered pairs, and to create the inverse relation, you swap the x and the y. For each ordered pair, so for this first example here, notice that this one is a function because none of the x values are repeated, but when we do the inverse, we take each x and y and have them swap places. That means that the input originally from the original ordered pair now becomes the output in the new ordered pair. So the input and the output switch places. Now in this new relation, this is not a function because if you notice, this 16 is a repeated x value. And because the x value repeats, it's not a function. Now let's go ahead and talk about how to do the inverse of a function formula. So if you have, for instance, this example, f of x equals the quantity 4x minus 3 all over 5, the steps are written in the box over here that you're going to switch the f of x equals into y equals. So we'll make it y equals 4x minus 3 over 5. And then you swap, just like before, you swap the x and the y. So you make it x equals 4y minus 3 over 5. Now you want to go ahead and solve for y. You want to get y by itself in this next new formula. So the first step is to undo the divided by 5 by multiplying both sides by 5. And by doing that, that will cancel out the denominator. So we get 5x equals 4y minus 3. Now we add 3 to both sides. So you're going to have 5x plus 3 equals 4y. And then we divide both sides by 4. And we get y equal to 5x plus 3 all over 4. That function is now the inverse of the original. If you put a number into the original function and then find the output, take that output and put it into this new one, it will then undo it and give you the original number that you put in. Now the notation we use for inverse is that same letter that we use for the function. Like if it's f of x, we use f of x, but with a -1 above. That -1 signifies that this is the inverse function. So when we use notation for doing an inverse, use that -1 above the function notation to show that it's the inverse function. Now let's go ahead and talk about how we're going to show that either two functions are inverses of each other or are not. Sometimes this is called verifying that it's an inverse or showing that it's not an inverse. Now the key idea here is that if you do the composition of a function and its inverse, it yields an x. What that means is if you do f of the inverse of the function, you get x out. Now usually we use two different letters for it. We use, for instance, f and g because we don't know if they're inverses or not. So what you have to do is you have to do a test. The test is you want to try the composition of functions, f of g of x, and see if that gives you x. And you have to do the second one. You have to do g of f of x and see if that also gives you the x, if they undo each other and give you the original number. So let's try this first one. We're going to do the composition of functions where we're going to do f of g of x. Let's see if that results in getting x out. So f of g of x means I'm going to take the f function, where there's an x, I'm going to put a parentheses, and inside I'm going to put the g function. So 1/7 x minus 2. Now let's go ahead and simplify that. 7 times 1/7 x is just x. That's very promising. But when we distribute the 7 to the -2, we get -14, and then plus the 2, that's on the outside here. And what you get then is x minus 12. That's not equal to x, so these are not inverses. We just verified that they are not inverses of each other. You don't even have to do the g of f of x. If the one does not work out, you just stop there and say that they're not inverses. Let's try to see if these two are inverse functions. So we'll start by doing h of j of x and see if we get x out from that. So that's where I take the x out of the h of x and I put in a parentheses. And inside, I'm going to put the j of x function, which is 6x plus 3 over 2. Notice that the 2's cancel, so what I end up with is 6x plus 3 minus 3 over 6. 6x plus 3 minus 3 is just 6x over 6 is just equal to x. So we had success with h of j of x. Let's now try j of h of x. Got to try both just in case. So in doing this, what we do is we go ahead and take the j of x, and we're going to take out the x and put in a parentheses. And in the parentheses, we will put the 2x minus 3 over 6. The 6's cancel. You end up with 2x minus 3 plus 3 over 2. 2x minus 3 plus 3 ends up being just 2x over 2 is equal to x. So yes, they are inverses. That verifies that they're inverses by checking both the h of j of x getting x and the j of h of x getting x. So the ideas here are, first of all, if you're trying to find an inverse, if it's ordered pairs, just take the ordered pairs and swap the x and the y. If you're doing a function, if you have a function trying to find its inverse function, then you go ahead and swap the x and the y and solve for y and find out what the inverse is. If you're verifying if two functions are inverses of each other, there really are two ways. The formal way is to test to see if the composition equals x. In both ways, you do the composition with both functions being the input for the other function. Or the other way to do it is to just take one of the two functions, find its inverse to see if it matches the other. So this is how we work with inverses, to find out both what is the inverse function and to verify if something is an inverse function of another.